So in this video, I want to take a little bit of a pause and talk about how in the rest of these videos following, you should be prepared to kind of know your derivative techniques, because a lot of what AP is going to ask you is it's going to ask you to combine, and a lot of what your basic textbook's going to ask you, like this is just kind of stuff you should know, is that you can combine multiple properties into one. And we kind of saw that when we did the product rule, because we did, the sum of a derivative, the sum of the derivative of a sum is the sum of the derivatives, and then we did that within the product rule. And so we've kind of seen that already, but I want to show that you can kind of look to the bigger picture. Like you can do the product rule with your trig properties. You can do the chain rule with your trig properties. And so I just wanted to show an example problem so that we can understand that we can combine multiple properties and still take the derivative. And so this is going to be a bit of a surprise. Maybe it's going to be a surprise. I hope it's not a surprise and that this is going to come very easily and we're not going to have to worry about it. But I just want you all to know that going on in these videos, I might be combining things like the product rule and the chain rule for review like into one video, or maybe the chain rule and some trig stuff. So I just wanted you to be aware of that as we go on. So we'll do an example problem regarding that. So we want to take the derivative of this function, and it's 5x times the square root of 25 minus x squared. And so I see that we have a product rule initially. These are definitely being, I'll show this in yellow, these are definitely being multiplied right here. And so there's my first term, and there's my second term. So we can go ahead and begin to take the derivative here. And so it's going to be the first term times the derivative of the second term, but we have a little bit of a problem here, is this can be rewritten as 25 minus x squared to the 1/2. So this term, when I take the derivative of this term, that's also the chain rule. So we also have to keep in mind the chain rule. So I'll go ahead and I'll have to use different colors to show the chain rule. But I noticed that this in green, we have a function being raised to a power. But within that, we have a quadratic. I'm not going to do it in red. We're already using red. Within that, we have a quadratic. So we're going to have to use the chain rule on this as well. So as we go ahead and use the chain rule on this quadratic, we're going to bring down the 1/2 power. So we're going to do the derivative, the 1/2, the power is the very outermost of our onion. Remember, we talked about the onion in the last episode. So we've got our onion. We're peeling off the farthest out layer of the onion, and that's the power. So, but we're going to leave the inside unchanged. It's 25 minus x squared, my bad. And we're going to reduce the power by 1, so that's going to be to the negative 1/2, because 1/2 minus 1 is negative 1/2. And then we're going to want to multiply by the derivative of the inside, and I meant to write the inside as orange, because orange is how we're representing the inside. So this is 25 minus x squared, but this to the negative 1/2. And then we're going to multiply by the derivative of the inside. And the derivative of the inside, well, that's the derivative of the constant 25 is going to go to 0, and the derivative of a negative 2x of a negative x squared is negative 2x. So we'll write that as negative 2x. But we're not done, because again, this is going to be I'm going to want to move this all out of the way. So I'm going to move this up here and then get rid of that horrible black space. We're not done though. We've got to keep continuing on, and we've got to, because we did the first times the derivative of the second, now we've got to do the second times the derivative of the first. So the second is the square root of 25 minus x squared. And the derivative of the first is just simply the derivative of the 5x, and that's simply just 5. So now we've done the calculus. We've combined the product rule and the chain rule. So now let's go ahead and see if we can simplify this derivative. So we go ahead and simplify this out. I'm going to go ahead and simplify this big term in here. And I notice that this negative 2 and this 1/2, these are going to cancel, and you're going to be left with the negative x, which we can see right there. So we're going to have a 5x times I'm going to then end up writing this in blue, a negative x times, but here's the thing is, recall from your algebra days that a negative exponent, so like x to the negative 1, that's the same as 1 over x to the first power. So basically, any x to any negative n is the same thing as the reciprocal of x to that n. So I'm going to take the reciprocal of this term And then, of course, 1 over anything times this over 1. Well, this is just going to end up going in the numerator, this negative x. So we'll end up writing negative x in the numerator, and in the denominator we'll put, and again, 1/2 we said is the same thing as the square root back up there. So this is going to be the same thing as negative x over the square root of 25 minus x squared. And so we'll have that. I'll make this parenthesis a little bit bigger. And then we're then still going to add this, and then I'm going to combine this term right here. So this will be, and I'm going to multiply that negative 5 in there too. So this is going to be let me get a color out for it. We'll go back to red. So this will be a negative 5x squared, because there's 2x terms. So this will be a negative 5x squared over the square root of 25 minus x squared. And we're going to add that. We're going to add that to 5 times the square root of 25 minus x squared. Now, if this were a free response question, you wouldn't have to worry about simplifying, and so you could leave this as is. But I want to go ahead and see if we can simplify this a little bit further. Well, to continue simplifying this, I'm going to go ahead and see if we can get a common denominator. So I'm going to multiply the top and the bottom by the square root of 25 minus x squared over the square root of 25 minus x squared. And we'll go ahead and see what that simplifies to. So I'm going to go ahead and get that f prime of x is going to equal negative 5x squared over the square root of 25 minus x squared. And we're going to add it. The square root of 25 minus x squared times the square root of 25 minus x squared, that's going to be simply just 5 times 25 minus x squared. That's simply all that's going to be, over the square root of 25 minus x squared. And again, we could simplify that. 5 times 25, well, 4 times 25 is 100. So 5 times 25, that's going to be 125. And then that'll be a minus 5x squared over the square root of 25 minus x squared. So finally, we could simplify this by adding the fractions together, and I'm going to get that f prime of x equals 125 minus 10x squared over the square root of 25 minus x squared. And that is how you can combine. That's just a little example problem. That is the correct answer. And that is how you can go about combining different properties of derivatives into one derivative problem.